Hello everyone. In this video, I'm going to talk about characteristics of carboxylic acids. And we know very well that carboxylic acids are formed through oxidation of alcohols. And I did that in a previous video. Now, the first characteristics of carboxylic acid that you have to know, they are weak acids and they have a pH of between 3 and 4. They are weak acids. They are weak acids and their pH ranges between 3 to 5. That's the first thing you need to know about carboxylic acids. The next thing, they turn blue litmus paper red. Because the acids, they have several reactions. They have several reactions. One, reaction with metals. They can react with metals. And you have to be specific here and categorical that only metals that are above hydrogen in the reactivity series. So I'm going to do a sample of reactions. Now I'm going to start with the group 1. Group 1 metals and their reactions with carboxylic acids. And in this, I'm going to do a variety of examples. Now, I can start with the lithium reacting with, can use ethanoic. In case as a student you still don't know what happens here, I'm going to put it in bracket. When carboxylic acids dissociates, they form CH3, COO minus plus hydrogen ions. This is what happens when they dissociate in solution. So when lithium is coming in to pick that part of the acid that has a negative charge and leaving the other part. So what can that one tell us? When this one remains, it is what is going to form the hydrogen gas that will be given out. So it's when we say that hydrogen has been displaced from that given compound. So that was just a by the way to make you understand the reactions that are taking place here. And we are going to see that. Now, having understood that, now we can proceed with our reaction. So we are going to form lithium. But this lithium is bonded to a O that is bonded to a C that is bonded to a CH3 plus hydrogen gas. So this is aqueous. This also aqueous. This is solid. I can reframe this and write it again. If you feel confused, it's written that way. I can reframe it again and write it as, because I know many students are used to writing as CH3 COO Li. When that happens is when we say we have formed lithium ethanoate salt. So this one we can call it lithium ethanoate salt. So the name is going to be lithium ethanoate salt solution. and hydrogen gas. So if you look at that thing, we really have to balance it. So when balancing it, we need to come up with a technique that will enable us know what we are doing here. Now, hydrogens are 2 on this side, and a hydrogen are still 3 here. So in total, hydrogens are 5. On this side, we have 2, we have 1, the 3, which is 4. So I can think of a number. I can think of any number that when I put, for example, I can decide to put a 2 here. Hydrogens now become 4. When I put a 2 there, I need to ensure that hydrogens are now 7 on the other side. So if I do that, no, I cannot really do that. Let me think of a situation whereby I'm bringing a value that will alter everything and make me deal with it. Now I'm going to have a 2 here. So my hydrogen this side, I put a 2 here. If I put a 2 there, lithiums must be 2 here. If I do that, what is going to happen? I'm going to have a 6 and a 2, which is 8. At the same time, I'm going to have a 6 plus a 2, which is 8. So lithium is balanced. The ethanoic acid is also balanced. Now, that's the first reaction. I'm going to do the second reaction. And in my second reaction, I'm going to use sodium. In my second reaction, I'm going to use sodium. Write as many reactions as possible so that you can understand what we are dealing with here. Sodium is Na, which is a solid, plus propanoic acid. So I'm going to have a CH3, CH2, COOH reacting. And that happens, I'm going to form CH3, CH2, COONA plus hydrogen gas. This is a gas. This is a salt in aqueous form. It still aqueous the solid. So I'm having my propanoid or the propanoic acid, sorry, and sodium propanoid. So this one is called sodium propanoid. For those who don't know the name of the salt, called sodium propanoid. Call it the sodium propanoid salt that's been formed. So, and to come up with a balancing technique, must think of a value that will help me balance hydrogen. For example, I'm having 1 hydrogen plus 2 plus 3 plus this one 6. I'm having them 2 this side plus this 4 plus this 7, meaning they're not balanced. So if they're not balanced, what do I do? Think of a number. If I put 2 here, what will happen? If I put a 2 there, the hydrogens are going to be 6 plus 4, 10, 6 plus 4, 10, plus 2, that's 12. Now, the same side, I'm going to put a 2 here. So I'm going to have 6 plus 4 plus this 2 here. So I'm going to have 12 on that side. Because I placed a 2 here, that 2 changed sodium this side to be a 2. So from that now, I can simply say that my reaction is fully balanced. Now, let me try a group 2. In a group 2, I can go ahead and do an example with magnesium. Magnesium, now I'm going to have Mg solid plus CH2 COOH. I'm going to have CH3, sorry, COO bracket 2 Mg plus hydrogen gas. Now, because I'm having two OH, I'm having two ethanoate, I need to make them a 2 this side. So I can decide to put a 2 here. If I put a 2 there, I'm supposed to ask myself, will the hydrogen be balanced? So I'll have a 2 here. So hydrogens will be 4 plus 2, which is 6. On this side, I'm going to have a 6. And I multiply with that plus this 2, 8. So it won't be balanced. I have to think of a number that will make me balance hydrogen and the noate part. So it means that I can decide to put that the ethanoate part, sorry, I did not write this very well. That's why I was having confusion in balancing it. This one was supposed to be a 3. Yeah. So if I want to balance it, I simply bring in a 2 and I put a 2 there. Now the hydrogens are going to be 6 plus 2, which is equivalent to 8. On this side, I'm going to have 6 plus 2, which is equivalent to 8. Properly balanced. Now, I can repeat the same with another element and another element. So what I wanted you to know, when carboxylic acids react with metals, they form salt and hydrogen gas as the products. Next thing that I want you to know about carboxylic acids is that they can react with bases to form hydroxides. They can react with bases to form salt and water is the only product. Now, next property that you have to know, carboxylic acids can react with bases. Bases are just metal hydroxides. When they do so, they form salt and water as the only product. So, can give it a try and see. So if I bring in sodium hydroxide plus ethanoic acid, I'm going to form CH3 COOHNA plus H2O. I'm going to form that. So you'll have to know that if that happens, you ask yourself, how many oxygen sodiums do I have? I have 1 sodium and 1 sodium this side. I'm not interested in balancing sodium. I have 1 oxygen plus 2, those are 3. 2 oxygen plus 1, still 3. So I'm not interested in balancing oxygen. The next thing that I should be interested in balancing is hydrogen. That is 1 hydrogen plus 1, that's 2, plus this 5. 2, 3 plus this 5. So the equation is balanced. So we don't need to add anything to it. It's properly balanced. Now I can bring in potassium. Is another example. Potassium is KOH plus propanoic CH3 CH2 COOH. When that happens, I'm going to have a CH3 CH2 COOK plus water. This is liquid, this is aqueous, this is aqueous. This one is also aqueous, this is aqueous. So when that happens, do I really need to balance anything? I have to confirm. K is 1 on the product side. Don't need to balance K. Oxygen is 1, 3. Oxygen 2, 3. I don't need to balance anything as far as oxygen is concerned. Hydrogen is 1 plus 3, 4 plus 2, 6 plus 1, 7. Hydrogen is 3 plus 2, 5 plus 2, 7. The equation is properly balanced. Now, the last note, I'm going to go to the reactions with metal carbonates. So, the third way in which carboxylic acids can react is with metal carbonates. They react with metal carbonates. And when they do so, they form salt, water, and carbon dioxide gas. Those are the products. Let's see that in a chemical reaction. We can do so by starting with sodium carbonate as an example. I'm having sodium Na2CO3 solid reaction with CH3COOH. What am I forming? I'm forming sodium ethanoate aqueous plus water plus CO2 gas liquid. Now, when that has taken place, do we really need to balance it? Yes. So I really need to bring a value that will make my equation be balanced very well. I'll simply put a 2 here. When a 2 is placed there, I put another 2 here, because sodium was to this side. When you do so, it is properly balanced. And try with the group 2, calcium carbonate. Calcium carbonate is my last example. Can have calcium carbonate plus propanoic. So what are we going to form? I'm going to form a situation whereby I'm going to have CH3, CH2, COO into bracket 2 with Ca plus water plus CO2. This is a gas which always escapes. This is a liquid, aqueous, and this one is a solid. When that happens, do I really have to balance it? Yes. So I really have to balance it. So calcium is 1. Calcium is 1. I don't need to balance calcium. Carbon is 1. Carbon is 1 the other side. I don't need to balance carbon. Oxygen is 3 plus this one 5. Oxygens are 2 multiplied by 2, 6, that's 4, 5, 6, 7. So it means that I have to come up with a value to help me balance oxygen. And also I have to balance hydrogen because hydrogens are 3 here plus 2. That's 5, 6. Hydrogens are 2, 5 times this 10, 12. I have to look for a way to make hydrogens give me the specific number that I want. So what do I do to make them 12? So if I put a 2 here, I can decide that because I have this whole thing into 2, so I can decide to put a 2 here. So that's how I'm going to balance it. Now I'm going to put a 2 here. When I put a 2 there, hydrogen now becomes 6, 10, 12. Good. On the other side we have 12. Oxygen becomes 2, 4, 7. Oxygen becomes 4, 7. Now our equation is properly balanced. Those are the 3 major reactions that I want us to talk about. So as a student, you really need to go through them and understand the 3 types of reaction, which is reaction with metals, reaction with the acids, and also reaction with metal carbonates. Those are the 3 major chemical reactions that carboxylic acid can undergo. Thank you very much and have a wonderful